Right, so customer drop-off. So you would get a random location and customer system, right. So at this point, the customer enters the car and now we should add a location or a destination. So we could attach it to the customer. Let's see, so we can just add a component. Drop off component. Which would have a destination. Yeah, I think that's it. And could draw that here. So we'll just do actually it would be nice to have like a query, like get a list of entities. Let's see. So the state right now has the entities is a list of like this. So if we make a function query, maybe we'll pass that in. This is what we actually have here. And then we query, and we're gonna query on Um, so if we had comp time t, which is a type, then we're looking at, so we're gonna return so either we can now wait. Yeah, I I'm just trying to think about this right now. I'm just gonna. I was thinking maybe we have you pass in list of entities and well, actually, we could just have one to begin with. Query for one component, and you pass in pointer to this array, and you get how hard is it to make an iterator in Zig? Let's see. So you basically just need a next function. Let's try this. Let's do query iterator, and we'll have function next. And we'll return, well, actually, this needs to be function because it depends on the type of the component. So this would be as in a type. And then this would return nullable t. And let's see. So we also need to initialize it. So we need a list of, so we need entities, which is this thing. And let's just have it here as well. We iterate t. Okay. And we need index. I guess we can have it like this. Okay. And we're looking for t, yeah. So we can do we're looking for entities. We get we get this. So now we have use yeah, and oh, this is the T. There we go. So this is a pointer. Okay, we get length, and then yeah, we'll just check. So we get the component is right now, but we also need the components instance. I guess we could we pass it here? Get T entity catch T. So this will now be the type, and then yeah, we'll just return that. And actually, we need to go from index to that. Once we've found the component, we need to set the index empty +1. And then this guy will return a query iterator type T. Return query iterator type C type T. All right, now we need to do this thing. Okay. And then I guess we don't. I guess we can add it here. Okay. Return that. Now we have init C entities, and we get the iterator back. Okay. So components. Okay. So now we can say all right, we have it like wrapped here as well. Get components. Query. And then we get component. Yeah. Wait. Yeah, because this is, yeah. So we get components max entities dot query iterator as a type. So we'll just return components query t and entities, which should be like that. I think. And now we can say state query for what was it? Drop off component. Right. This would give us the iterator. While next we get the drop off. Yeah, the LSP can't. Okay. So this is a variable. We don't get any language LSP help from this, but yeah, it should work. This shouldn't be any issues, except it's under capture. So here we can say here we can say, yeah, we want to draw the drop-off location. So I'm just gonna draw a rectangle. Using drop-off dot position. I'm not sure what it was. Destination. And size. Let's do let's do like 32 by 16. And then 24. Color red or green. Something, I don't know. Okay, so now okay, so components const. Ah, okay. Var. Okay. So now we need to generate the drop destination. So let's go to our customer system here. We should add this component, or set component. And it should be one entity, and it should be break down the destination is get random location. So yeah, this. So we actually need. Well, this kind of becomes like a circle dependency. I'm not sure if that's possible here. Unless we can. No. Because we need the scene. Well, actually, maybe we can. We can't have a scene here. Well, we can put a bunch of I mean, I guess we could add them as entities. Probably the correct way to do it. Add the locations so that we can look through the locations in the state instead of relying on the scene specifics. Yeah. So let's add. So we have drop off component. So this is supposed to be on the customer, but then we should have location. Let's do like entrance position. And now destination could actually be like an entity ID instead. But let's just keep it as a vector for now. This would be location. This is not scalable, but it's what we got right now. So at some point, this will have to be replaced with like a bunch of array lists or something. Okay. So also instead of an iterator, we could also have just because returning a slice would be we're gonna have memory issues. Because what I wanted to do is check like what's the size of the query, like how many things, and then get one random from those, and then choose that as a random location. Um, I mean, I guess we could, if you pass in an allocator, it could return a list that you have to free up, like a temporary thing. Or you could pass in a buffer. Let's just do the most simple thing for now. And get query to buffer. And this would be, then, yeah, you would need a buffer. And this would be a slice of use size const. No, not const. We need to write to it. Use size, yeah, just a slice of use size. Then we are going to call query with T and entities, and we're gonna loop through that. Let's delete R as well. And we're gonna get the next component. But it's not the component that we're interested in. Well, okay. I guess in order for this to work as well, we need to have like more than one type. So it's not really gonna work either way. Unless we do like variations, we add like faking overloads with more than one component type. And I think if you want to do this correctly, you might need to do something more advanced with the comp time stuff. Like you pass in a tuple of types, which is then mapped to a resulting type which has the components on them, and then you can do that as a list or put it in the buffer. But just wait. Okay, we can do like this instead. Let's skip this for now, and we'll do it here. So to get the random location, we would just do we need a buffer, and so this is like the location candidates. This should be a list all view sizes, and we'll initialize undefined. Then we get an iterator for, actually we'll just do like this. So we'll do 0 to entities length. We'll get candidate and we'll do, well, actually we can just do it in everything in line. We don't need to build a list and stuff. We can just do well, actually no, we do need to keep track of the entity IDs, because when we choose a random one, I think we need it. So we're just gonna check here if we meet the criteria. So we're gonna do get component, and this is gonna be transform. Actually, maybe we could do an array. Could you do something like this? Can you do this? And then you say like transform is transform. Let's just try that. So we get transform and catch to no, wait. Oh, candidates. Okay. Um, okay, seems to work. So we get the transform, and then we get the label. And if label, so label is equal to house. If it's not equal, then we continue. And if it is equal, we have a candidate, so then we put that into our candidates, which we need an index for. So then this would be transform. Okay. And then we also increase the index. Oh. Let's do. Okay, seems to be fine. Cool. Yeah. So now we should have a list of candidates, which is LCI long. So now we just need to get random candidate index, which we need. Yeah, we need a random. So I'm just gonna make a random here. Okay. Except this needs to be var. Okay. Does this work? Yeah. This would be random. And then most, what does that mean? 0 to at most or less than. From 0 to less than, yeah. So this is your size and at most LCI. Now we have the random, and then we can say that the destination location candidates random candidate index dot transform. So that's the transform. Now yeah. Now the transform position is not the same as the location that we want, I don't think. Wait, going through each. No, we need what was it called? The one that I just added. The location component. The location component. Not the label. Okay. And the location component. So this is the location. So we're getting a random location, and I mean, I guess we also need to check if it's. We can do it here actually. We can just check if the distance. So distance to we can. Yeah, it doesn't matter. Distance to the position of the location distance will be, so if this is less than, I don't know, 256 or 512 or something, I don't know, then we actually don't get a location. Also here, if LCI is 0, we have a problem because we don't have a drop-off location. So yeah, let's just not worry about that for now. We're gonna get this. Will this crash? What if less than is 0? Okay. Yeah, I guess this would be, it would crash here, out of bounds. Or not out of bounds, but it would access, actually, yeah, it would access undefined memory, and then this would point to garbage and crash. So let's just say that this is unreachable for now. And I guess that will crash more in a better way. Okay, so the location. So let's copy that pointer also, location, and we'll put that in here. Okay. So I guess the location component, it already has like an entrance position. It already has like a position, so we actually don't really need the transform here, right? So let's get rid of that. Unless location is, it's not absolute, it's relative. But let's just assume it's absolute for now. So we don't need transform, we just have location. And then, yeah, we can use location instead. Dot position here. And we can remove that. Okay, so now we got that. And we get the destination. Now this would actually be just constant where we have a location as positioned that. Okay. And this one resides. Comp time value. Let's see. Uh, you know what? Let's add it here. Let's add it to state. State is for everyone, so we'll just add the state here. So we'll just set random. So no, it's not random. It's I'm not sure actually what the type is. Whatever is the return of this, let's just set it equal to that. That way it will hopefully infer that. Maybe? No. Okay, let's just type that out. Okay. Wait, so it is? No, wait. Yeah, okay, whatever. So now we have that. Now we can look. And when we're using rand, yeah. No, I'm not gonna do that. I'm gonna remove this, remove rand. What's happening? This guy. I wanna remove you and then go back to where I was. I was in. Where was I? Customer. Yeah, and now this would be instant render instead. There we go. Cease unused. Oh. Expected that, found that. Oh yeah. And then return null. Okay. Okay. So let's do customer enters car. Custom system. Yes. Let's also get customer. And player center point. Now do that. And we also to move here. Okay. To continue instead. Okay, so yeah, we don't have any locations, so this will actually crash. Let's just test that. Yeah, great. Then, yeah, let's add some locations then. So initial scene, meet house. We need to add location component. And we can actually do get better drop off location. These will be the coordinates that we need to translate the entrance with. So we need the entrance position. Which would be transform. Okay. And then this would have entrance position. There we go. Okay. So now we have the location component, and we should not crash now. Okay. we're constantly crashing into this pedestrian. Let's change the crash sound so it doesn't play whenever you do that. Um, hmm. What would be an easy way? Yeah, I can't really think of a really easy way to do it right now. I'm just gonna disable this now. Okay. Yeah, now we don't have crash sounds. But yeah, in theory now we should also get the drop-off location. Okay? So in one of the houses should have a drop-off location. Probably should have just logged it out. Is it in the last place? No. Okay, let's see. So we have destination. We are drawing in the drop-off area. Let's do that. Oh, okay. Wow. Okay, so we're actually triggering this each frame. Yeah, we need if it doesn't if it ah. So the player should probably have some sort of tag that says that you have picked someone up and you can't pick something up anymore. But we'll just do here. So you have we get the drop-off component. And if we actually get the drop-off component, then let's do get option. Is this really the correct type? Yeah, okay, because we're okay. Yeah, so we get a pointer to a null value. So what we want to do is if we actually have if drop off is not null, then we actually just return because we can't pick anything up. And this, I guess this will only work if we only have one customer at a time. Otherwise, we need to put some tag on the player instead. Okay. Yeah. So now it shouldn't. Trigger every frame. Okay, cool. So we've got the drop off at negative 320 and negative 288. So let's see if we can find that. Should be somewhere in this place, but I don't see it. It's the last thing we draw. It's green. Let's make it black. Let's also check if we actually go in here. Yeah. So we are drawing something somewhere, or we should. Oh, wait, I know. Okay. Yeah, we're drawing it off screen because we're not translating it to screen or with the camera. So we need screen, camera, robot explanation. Okay. Yeah. Somewhere this, yeah, okay, yeah, here we go. Okay. Let's also offset this. So let's do W. Let's do 6 or 48, 32. Wait, I think they need to be. Okay. Okay. Yeah. I guess it needs to be a bit further down. The actual drop-off location. Let's do 128. Okay, yeah, that looks better. Hmm. Make it a bit larger. And we will draw it. Draw the application. Okay. And we are drawing this. I think, yeah, we draw it here. So that the entities will be drawn on top of it. Okay. Okay. So we got the drop-off location. Now we also need the customer to exit the vehicle. So this will actually be interesting because now we can say here that if we do have a drop-off location, if we do have drop-off, then we return and we also handle drop-off. And what we're gonna do here is we can get the entity and we can say let's get drop-off component. And this is the customer and cache original. So then so we got that. So this will be the destination of the players or the customer. So the customer is basically gonna just aim straight towards the drop-off location and go to it. And we also want to add back the animation and texture. So maybe instead of removing, we can disable. But how would you enable? For disable, we basically would need double the lists. Or we could just add them back as they were, but we don't have the specifics of it. Okay, this is a bit hacky. Let's just add don't render or invisible. Okay. So instead of removing these, we can just add reset invisible. Okay. And now here we can just remove invisible from customer. And then we need to move towards house or location. When location is reached, customer gets removed. So that would have to be another state that the customer is in, basically. Maybe we should just have like a customer. Wait, don't we have? No, we just. Wait. Don't we have a customer component? Oh, we're going off the label. Okay. All right. So yeah, we could add a customer component, and you would have like a state, which is yeah. I mean, we could do struct. I think this is how we do it, and then you say drop off, which is this. No, union. Yeah. Okay. And then so we have drop off destination. We can also be. Could you just add or like this? Yeah, and then we need state. Nice. And if it's drop off, we can. Nice. That's really cool. Okay, so drop off destination, and then what we can be is we can also we can be inside the car, which also would be transporting to drop off the location, and then walking to drop off location. And then we can also be waiting for transport. Okay. Then we don't need this. No. So now we can actually get we don't get that, we get the customer component. Then yeah, after entity. Then if we don't get it, we continue. Drop off does not exist. Here we say if customer component state is transporting the drop off. Nice. Yeah, and then I can capture it, right? No? Or I have to switch. Yeah, okay, let's do that. Let's switch on state and this now is the same. Okay, cool. So drop off, handle drop off. And we can pass in that which would be customer dot state. Oops. Dot state. Can I say that it's a specific state? Or I guess I could type these. Or name them. Drop off. Yeah. And then I will get a drop off here. Customer component drop off. Okay, we also need to we can get the customer components, which would be customer components. We'll say customer component dot state is equal to walking to drop off, right? And then we say parallel walking to drop off. We'll do that. So go to drop off when reached customer gets route. So we just update the state here. Next tick it will start walking. Yeah, so we remove invisible, we change the state, and that would be good. Now, don't set that, let's see. Let's have this walking. And let's, yeah, because we need the physics on the location. Let's pass in the customer and the drop off. We're gonna get physics, catch, unreachable. We need the physics. And now we need to calculate the angle and stuff again. Just gonna copy this for now. So dx would be drop off destination x minus, oh, we need a transform as well. Transform and from the position of x and drop. Oh yeah, we need a center as well. Here. All right. Then, oh yeah, and also drop off destination x plus no. Let's just do this for now. The dy is of apply. This should be good. Okay. Then, or we can do it here. If distance to drop off is less than, I think, 16. That's what we say for the car. So let's say that for house as well, 16. Then we've reached the destination and we can remove the customer. So we have, no, we don't actually have remove entity yet. Destroy, yeah, we have destroy entity, yes. Okay, destroy entity. Destroy. It will remove all components as well. Customer and return. And then we also want to signal this somehow so that the player can get score. Yeah. All right. So now also let's do the last one here. Waiting for transport. This time we basically do this part. So let's do hello waiting for transport. Don't need to check that customer label. Let's put all of this into here. Handle waiting for transport. With this entity. And we rename that the customer. Continue. Yeah, this would be return instead. Oops. Let's see. Player transform. get that layer physics. Okay. Um, ah, yeah, and here we don't set the drop-off component. We actually get the customer transform component. So we have the customer component from here. Let's put that in here, customer component. Pointer. And then we pass that in here. And you receive this. And now, instead of doing this, we do. Yeah, where it goes. Yeah, it's going forward. I'm doing the drop off of the customer right now. I had to make a bunch of components and stuff. Currently in the system, customer system part. Let's see, so here we're selling drop-off component, but we don't have drop-off component anymore because we have customer component, and customer component we set state to be transporting to drop-off with destination this. How are you then, Verticos? Um, see, this needs customer components. So I have this an error. Okay. Shouldn't be. There we go. Now I need to adjust here. So, right. Need to query for that instead. And now we get the customer component. And we need to say state. And this is going to be if we are transporting to drop off, then we get the drop off. And then Then we do this. And okay, so else we just continue. I'm investing my time in Hyperland config currently. Oh, what's that? I download default Win 10 wallpapers and play around with the way bar. No, I don't mess around with that stuff. What's Hyperland? Okay. Smooth slope. Okay. So now, I mean, yeah, we don't have any errors. We need to add the components to the entities. Oh, initialize customer. We have label, transform physics. Yeah. So we need customer component. State going to be interesting. Right, because it doesn't. Okay, so it doesn't know yet. Let's see. Now we get these, and this is waiting for transport. I guess this could be default. Okay. Hyperland is desktop environment for geeks who did not show 10 years. Okay. Desktop environment. Hyperland. I've heard about Wayland, but I'm not sure what it is. Hyperland provides latest Wayland features, dynamic tiling. Okay. Oh, it's like a window manager. Aha, is it for Linux or is it for Windows as well? My wife is Windows 10. Linux only, yeah, okay. Yeah, a long time ago, when I used Linux, I had something called Xmonad, which was like a Haskell-based display, or what you call it, like window tiling manager. It was pretty nice because you could change the layout with like some combination of spacebar or something. I don't remember exactly, but I remember that it was nice to have the windows like neatly positioned and not having to worry about a lot of floating windows everywhere. But yeah, Hyperland looks like sort of like that, but the modern version. A lot of fancy stuff. Yeah, you can edit it pretty neatly. Several desktops. I mean, Windows does a lot of these things, so that's actually kind of nice. Like multiple desktops and a little bit of tiling as well. It does enough for me to not thinking it's in the way. So are you running like both Linux and Windows? All right, this says customer, the house, location. Let's see. Oh, I was walking to the destination himself. Okay. Also, the rendering was kind of weird. Hmm. Or the draw order of the entities. He should have been behind that house, I feel. Let's see. So, yeah, that works. I switched like a month ago, so my HD is a fresh untouched Windows 10. Some bad things happened. No issues so far. Didn't need new debut. So you switched from Linux to Windows, or the other way around? Because I think Linux and Windows, they have different. Unless you're having it on a separate disk or separate volume. Because I think they have different file systems from Windows to Linux. Okay. Yeah, I'm not sure. Maybe it's better now. Uh, so you have, I mean, from what you said there, Do you mean that you have your Windows 10 intact from the switch to Linux? Yeah, okay, so in the custom system, we need to update here. The drop-off location. Walking to drop-off, no? Yeah, handle drop-off. So we're waiting for the transport. That worked. We enter the car. We change the state to transporting to drop-off. Oh, wait. No. Yeah, transporting to drop-off. Then we handle the drop-off. This, so we don't know if we reached the destination yet. Yeah, okay, yeah. We need to do this again. Wait. No, it's not handle drop-off, it's handle transport to drop-off. And we need these. And we're checking the distance. If distance is enough, we should also check player speed. So let's get player physics. Oh yeah, we have it here. Player physics. So and player physics dot velocity length should be less than 100. Okay. Then we handle drop off, which is just these things. So we can just do this. So we are removing that because he exits the car and then changing the state to walk into drop off. We should also, I just realized, we should make this mutable and we should also move the customer to player. So let's make this mutable and say customer C should be player C. So we should also get player position. Player transform. So now we have player C. So this should be player C. Y is, wait. No, actually, we do transform. And then we offset back whatever this is. So we got 8 minus 8 minus 16. Okay. And we don't call that, but here we need player physics, player transform. All right. All right. So we're waiting for transport. This all works. We're entering the car. We set it to transporting. Now we're handling the transporting. The customer is in the car. We check if the distance to the destination is less than something, and then we also check if the player is not moving or moving slow enough, and then we make the drop off and we transport the customer. We make the customer visible and we change the state to walk to the drop off. Okay, if it's not so this part is not necessary here. And we don't need that. Okay. How does it look now? Okay. Let's see. Let's. Whenever the state changes, I want to log it. So customer state will be transporting to drop-off destination. To this Yeah, guess otherwise you're just waiting. Okay, that's the only thing. Transporting to drop off. Okay, so that. Oh, yeah. Okay, so it keeps moving because we're not resetting the physics, which shouldn't really matter, but I mean, it should really be like totally disabled, like the physics and transform and everything. Should basically the whole, yeah. But let's not worry about moving around. Let's do. So it wait, if we're transporting, like it should be the player. I mean, to some extent, the customer should actually be moving with the player. So we should actually update the position here to be the same as player, like this, all the time. So now we should actually see the customer being transported almost in the car. Or it should follow the car. Yeah, now we got them. And we go to the destination here. Ah, okay. Yeah, the drop off, the location disappeared. Okay. Went a bit fast. Let's see. Let's do like 32 and walking to the drop off. The distance. Let's do like 2. Okay. Yeah, I mean that works. Except we want like the walking target to be more uh, more upwards. So let's do. I'm just gonna use add here. Add. No. So. Uh, so this would be the drop-off destination. X is good, but the Y needs to be offset by 32. And we're gonna check if against the target. Move towards the target instead. Okay. Okay, nice. Okay, so now you can drop off customers. So you can actually drop off customers. What? Yeah, okay. I'm missing an LSP here. Yeah. All right. So, yeah, you can do customer drop off now. We don't spawn new customers though. Let's add that quickly here. So, I guess the customer system could handle that. Well, actually, no. Because we don't have the components and everything that you need. I guess the scene could check if we have a customer, and if we don't, we add one. Not really efficient, but it works. We're gonna just go through entities, and we're gonna check, do we have a customer component? So state, get component, customer component. Okay. And we are going to check continue. Let's do has customer expose. If we have a customer, then this is true. Actually, Yeah, wait. No, if we have a customer, then we return. Otherwise, we will actually reach this point, and then we do, yeah, then we create a new component, a new customer. So we basically just initialize customer again. So we will get another customer somewhere. This isn't used, so let's do that. This needs to be a try. Okay. Oh, yeah, okay. Let's just do this. Okay. No more errors. Let's check if we get more customers. Now, once they enter the building, we should, yeah, there's another customer here. Okay, so now you can actually play this game by moving these customers. Ah, I found the target. And once it's disappeared, we should get another customer somewhere. Yeah, I mean, it works. But it doesn't feel like good to slow down that much on the pavement. Yeah. Whatever improvements I can make to make it more, a little bit more fun, that's not too much of a hassle, would be nice, but yeah, okay. Yeah, also the animation is not playing. So the customer starts out by not having an animation, right? It's paused. So in our customer system, we can actually get the animation here. And of course, when we're walking, we don't want it to be paused, but we want to do this in the transition. So here we get the animation. And we say animation unpause. There. We should also do that when we are transitioning to when we're entering the car. Wait, no, not when we're entering the car. I mean, I guess here. Here. Yeah. A red arrow pointing where you should drive to. Yeah, I thought about that also. The should probably have that. Make it easier to find. I mean, it's not that big of a map, but It would be cool to have the arrow. Oh man, the animation. Oh, okay, yeah. Right, okay, first off, I want to hide. Actually, I thought of this. When we are transporting the customer, we can actually set the Y position to be a little bit up. So let's do 8, and then a little bit to the. No, that's not gonna work. It depends on the play. Yeah, I thought we could do it so that it looks like he's like sitting in the car, but I would have to know the player like direction. I guess it's possible, but it's too much of a hassle to do it from right here. So I'm just gonna implement like when something is invisible, it's not gonna get drawn. So in the draw system, we're gonna get here if we get an invisible. Wait, transform. Wait. Um, there. If we get the invisible, it's the optional here. So we get, so we say if invisible is not null, then we continue. So now we should not draw anything that has invisible. So when he enters the car, yeah, and I know why it's like spazzing out. Oh, okay, something weird is happening here. Oh, nice. I'm making the world disappear as I. Okay, yeah. This clearly didn't work as I thought it would. Let's see. Yeah, the draw order. Why shouldn't this work? So we're going through. I mean, I guess we can filter it here as well, but whatever. So we're going through each entity. Oh, wait. Right, so that's the entity. Okay. Yeah, this is too much of a hassle. I'm just gonna do this. And then in here, I'm just gonna do it here. So there we go. Now, Okay. And then it reappears over here. Yeah. I just want to adjust this a little bit. So let's do like player speed when picking up should be like, I don't know, 32 maybe. Right now it's 100, which feels a bit too much. Okay. Okay, whatever. So yeah, an arrow. Yeah, I was actually thinking about that. So maybe we could do it now. Thinking about how we could do that. I mean, so we have basically the camera position and the camera size, and we can because I think usually they do it by having the arrow. You can draw like from the center of the screen, or if you imagine a line going from the center of the screen to the destination, and then where that line intersects with the screen edge, that's where you draw an arrow, which is also rotated by the same angle as well. So what we could do is we could go to our scene, and we can add a function called draw target arrow. And we would need the state and so actually we could just save the whatever, let's just do it like this for now. So let's just grab, I mean, we could do this, we could go through each customer, and then we go through that. This needs to be variable. We go through each customer. Now we have a customer. It doesn't say it, but the LSP doesn't know about the comp time stuff. I added this query function that returns an iterator, but it doesn't play nice with the LSP, which is quite annoying, but yeah, it is what it is. So we get the customer, and then we can say switch customer dot state, and then we get if it's waiting for transport, then we need to get the transform from the customer. So we don't have the entity ID here. Or do we? No, we don't. Maybe we should return both. Okay, let's not do it like this for now. Let's do. Let's do. Well, I guess no. Let's do. Let's do the for loop instead. I mean, we're basically doing that anyway. Entities. We get the entity. We get the customer component. Customer component. Entity. Continue. So we're gonna do this here. We're switching on the customer state, waiting for transport. Now we need to fetch the transform from this entity. And if we don't have it, that's not reachable. Transform. So yeah, so then we need another function. What we could do is have this be get target position, and we just return transform that position. Then yeah, so we'll return that, and then we also do if we are other two these two. We get a drop off. So then there we could just say drop off dot destination. Okay. And hopefully this will return, or do I need to say return? Yeah, I think so. Okay. Otherwise, yeah, so this will be like a, wait, I can return like this. That's not an error. All right, it's not compiling this function. It's not checking the function because we're not using it. Okay, let's see. Draw target arrow. So we have a scene. I think we need that. Oh yeah, we do need that because we need the camera stuff. So state. Okay, so we draw. So we get the position. Target is get target position. State. Okay, now we also draw this. We can draw it at the end of everything. Draw target arrow. Now we should get some. No, I thought that we would get like errors because this is void and we're returning stuff here. Huh. But yeah, expected type void. Why don't I get? Okay, now I get it. Yeah. So void. This is vector2. Let's make it inline, just in case. And it should be nullable. Because if we reach here, we didn't find anything, so we return null. And here we have the target, or else return. Yeah, and it's unused. So now we have the position. Now we need to intersect it with the camera edge. So the camera, we have the camera here. It's actually a custom struct. And we have a rectangle. The position is in the center of the screen. So X and Y is in the center, and width and height is the width and height of the rectangle. So to get the intersection point, I'm not quite sure how to do that. But I mean, it's probably is really easy. You got what? The edges of a rectangle though. So you got one line, which is like this. And the rectangle. Yeah, this is too complicated. I need to look this up. So line intersection with rectangle edge. It's not that straightforward. Yeah, you need to check each edge. Does maybe Raylib has something? They do have like race, but that's in 3D. But I guess you can use it in 3D as well. So we'll do ray is a struct. Right. So we'll start from camera. And set 0. And then box min max. What? Bounding box. Is it? So we got two vectors. Mm. How does that work? Is there something else, like a rectangle? Right? Wait. Can you get collision, check collision. I mean, you can't do that. Let's see. Do we have like something like line? Do we have check collision lines? So we could do a bunch of lines. I guess we can make check collision point rectangle, point line. I guess we have to do one for each edge. I mean, there may be like a really more very simple way to do this, but let's see. Let's just so we'll check the top and we'll do so we got the target and we need. So basically, yeah, we get the target and then we also need the source, which is the camera. Let's do initialize there. So start is always going to be source and is going to be target. Then start push, end push. So that's going to be depending on the edge. So a top will be top start will be so this will be, let's do width. We also need to scale it to get the correct one. So we got right and we can get the top left. Right. So we get the, we do this. We get top left is going to be we can do top as well. So we'll do source dot y minus this, and then bottom is plus, and then this is for x, width, left, right. Okay, top left will be LT, top right bottom left, and bottom right. So then this will check from top left to top right. And we need a collision point, so let's do a collision point is a vector 2. We'll pass that in here. And then we'll check if, I guess, wait, how does this work? Bool, okay. So we're checking if this is true. Yeah, I guess if it's true, then it's collided. So if it's true, yeah, we should really have this as a function also, like get target screen edge position. This will be 2, and I need the scene and the state. And move this over here. Okay, so if this is true, then we can just return the collision point. So we got top, we've got, let's do left, which will be top left to bottom left. Then we have bottom, bottom left to bottom right, and right, top right to bottom right. Okay. And where that is intersected, we're gonna get a point. Now, there's also going to be a bit of offset. The position can't be larger than, so we're gonna move back. Let's see. Yeah, because we're gonna need the angle anyway. So what we could do is here we can pass in the target. And the source. And then we calculate the angle here, because we need angle to rotate. Like if I'm thinking of just making an arrow picture and then rotating that along the edge. Or is it better to have, I mean, it's probably way easier to just have the arrow be like in a circle around the player. You could do that as well. I don't know. Let's try this for now. So we get the target, so we get the edge, screen edge position. target source. Then we don't actually need state. Great. So we got target position, and if we were just drawing the arrow on this coordinate, it would actually be halfway outside the screen. But what we could actually do, we could actually here, we could do this WH, we could just lower this by the size of the arrow times 2. So let's say the arrow is 64 by 64. So we'll do 128 here. So now it will intersect with a box that is slightly shrinked from the screen edge. Okay, yeah, then we don't have to do any weird stuff. Okay. And then we do, so now we have this. So now we can just draw this. With this. No, not draw text. Draw texture. And we don't have the texture yet, but let's add that. So we have the target arrow. And let's grab that. Okay, source. Source is I was thinking if there was like a rect from here, but no. So let's just do rectangle in it, and we're just gonna do target width. Oh, we need to cast this. Oh, okay, let's just do it. Right, color. Oops. Actually, we could make it grayscale and then adjust the color here if we want, like more than one arrow color. And then rotation is going to be the rotation that we are going to calculate. Let's just make that 0 for now. And then we have the origin, which how did we do the origin? Origin was like this. So it's the, yeah, we need the destination rectangle. This is gonna be screen edge, and wait, no. Yes. No. Yes. No. I don't know. And this is, we're just gonna set this to 64. Okay, so we have destination. Let's just do source T for texture. Now we have source T, destination, and the origin. Okay, please format. No. Now, there we go. And this we need to do add as f32 load from int. Two parentheses. Okay. Member wait. There. Non-void return. Okay. Yeah. So here it's actually unreachable. No, wait, it's not unreachable. Because if we're here, we haven't collided with any of the screen edges. So that means that the position is on the screen. Which means, where do we draw the arrow? Then probably somewhere along the way of player to the target, or we can just hide it, I guess. For now, yeah, that's the easiest way. We just hide it. So let's have this return nullable as well, and we can return null here. And then I mean, or because we have the target, we could do a collision point around the target. Let's do that because it's kind of nice. You just do check collision, like circle line. Perfect. Circle. So circle center is the target. Radius. Let's do 128. Maybe that's a bit much. No, we can adjust it later. So, and then the line is from source to target. So, I mean, it's always gonna collide. Wait, we need the point, the collision point. I mean, I guess we could calculate it as well. Okay, whatever. Let's just do return null. Okay, so Yeah, this guy, if we don't get this, we just return. Great. So now we get the source. Here we get the destination, which is that we get origin, which hopefully is correct. So yeah, let's see if that works. But we also need to make the actual arrow. So let's do that, 64. And let's make it grayscale. And let's make it point to the right. Not sure how they should look. I mean, it's not that important, but I'm having a case of OCD here right now. 32. There we go. And let's just do up somewhere. 35. Now we're at 23. 22. And then 42. Right. Yeah, it looks shit. But yeah. Let's do that. And that. Why not? It looks very off center. 22. Okay, so wasn't that off center? Okay. And I want a little bit darker on the edges. So let's do no. That. There we go. All right, that's a good enough arrow. It's not. I mean, I am actually annoyed by this part. Why is this like so off center here? This is the middle. Yeah, I'm making it red. I'm painting it gray or in grayscale so I can tint it with Raylib. Not sure how it's gonna turn out, but we'll see. So this will be the target arrow. And minimize that so we see the code. Now we should have it, and it should be visible now. Yeah, let's see, let's test. Hopefully it doesn't crash. Okay, we've got an arrow. It's not really pointing. I mean, okay, so it's kind of mirrored. I see what it's trying to do here, but it's definitely not correct. Okay, why is it doing that? So I have this screen functions to make things. Yeah, but that's, let's see, let's go through here. So this thing, let's log this out. So we've got top left, top right, right, top left, top right, bottom right, bottom right. So that is the camera coordinates. Well, yeah, and they are like on the map. Well, they follow the player coordinates, yeah. And then we have the target, which is the transform there. So that is the same coordinate system. Then this, right, so it's not really the screen edge. I mean, it's the screen edge position, but it's not translated with the screen thing. So we should be doing, okay, let's do it outside. Let's do it here then. So arrow position. Let's do screen and camera adjustments. See if that looks better. No. Okay, let's log that. Arrow. Well, oops. So it's way off. Huh. So we should be getting like world position here. Yeah. Maybe we don't need. Let's take this off now. Still the same, basically. Okay. Because the size is like half of what the x coordinate looks to be, and y is even larger. So are these positions wrong? I don't think so. What if we just say that this is, let's just do this. Let's just say, what if it's in the middle? Okay, it's not even shown in the middle. Oh, wait. It's in the middle in world coordinates. So it should be over here. Yeah. But that's the thing. We don't want to translate to world coordinates. And that's the camera. We want to do it the other way around. So we want to subtract. Vector x, vector y. Okay. World screen. Let's see if that works better. Nope. Ah, here it is. All right. Interesting. I mean, yeah. Yeah, the camera shouldn't really be. Yeah, we want world to screen, but it doesn't seem to work that great. And then this one offsets it by half the size. So 0, 0 should be in the middle. Yeah, and this doesn't work, so why not? So we have the camera position. We are intersecting into things that are relative to the camera position. Then we translate by removing camera position, so you get the relative position from the camera's origin. So it should work, but I'm missing something here. Because otherwise we're just doing the same thing. We're adding. So now it should just end up in the middle. Yeah. X and Y, X and Y, X and Y. I mean, this should just end up in the middle. Wait. No. Okay. Let's try this. Yeah. Okay, let's try that. Okay. I mean, it's kind of mirrored, or yeah, it's flipped in the y-axis, I think, or I don't know. It's not. Also, it's wait. What is the camera rectangle actually? What's that? It's yeah, it's screen size. H top bottom. Such a weird collision to get. Top left to top right, top left to bottom left, bottom left, bottom right, top right to bottom right. That looks good. Oh, disappeared. Why? Okay, yeah. Okay, so it's the origin. This is a drawing of the arrow. The origin is wrong. I feel, or this is wrong. Yeah. So we'll just do 0, 0 here. Okay. So now it should disappear. It's kind of weird. The math isn't quite right. Let's do this. So we have the target and the source. We also want to have the angle towards the target. So we've got towards the target, source. We've got the angle, and there we go. So we got the angle. Let's see how that looks. Right, because this, okay, yeah, because this guy is actually the angle in degrees. So I think there we go. Okay, I mean looks it looks like it's following the screen pretty good with the angle, but it doesn't point to the correct place. What's going on? So a little bit confusing. Is the target position wrong? So we're getting, so this guy is waiting for transport, so we should get the transform position back here. Let's just log that. So it says negative, yeah, that's, I think, yeah, that's correct. So negative on the x-axis and then way down on the y. So that looks correct. Negative 64, I guess. Okay. So that's the target position. Wait. This is the source. Wait, no, this, yeah, this is the box around. Uh, and the source is the camera. Top left, right. Wait. No. It should be. I mean, instead of going with the camera coordinates, I could go with the player coordinates, probably better. Yeah, let's do that. So let's not this. Let's go player transform. Get component transform player catch unreachable, and then instead of camera here we say player transform position. We can just say player transform. I mean that would be hopefully more correct. Okay, the aggro disappeared. Okay, so interesting. Width and height shouldn't matter. We've got source. So we got a line from the source to the target. The source is the player. To the target, which is the transform there. So this should be more correct, but it's not drawing the arrow at all now. Top left, top right, bottom. Yeah, it's. I need to go to bed soon. But we almost got it. I can feel it here. So player transform is the source. This position. Let's log it. Let's log screen edge. Let's actually do this because it's way more easy to read. And I think you can do stuff like this to get it. I really need the let's try that. Found. Or is it just the dot zero? No. Zig format dot d colon dot. So it's off screen, of course. It's like, I guess, close to the player. So let's see, what is this? Let me try to translate it to the screen. Okay, it gets further away. So let's do this. There we go. So a bit large maybe. Yeah, but it works. I mean, it doesn't really point to the correct place, but I mean, you can use it to find it, at least. I mean, yeah, it really reminds me of like the first, like the GTA 1 arrow. What if we, okay, so yeah, and then it points to the target. That's kind of cool, actually. And then when he enters, we get a new target. Yeah, so I'm actually slowly building the old GTA game. No, I'm not gonna do that. Who knows? I mean, this is basically a GTA. You pick people up and drop them off somewhere. Okay. Yeah, I mean, I can find things faster now. It works. Just need to fine tune the arrow a bit, but yeah. Okay. Cool. Yeah, turns out this function here was, I already have the world to screen, which is this one. It's just other stuff that didn't work correctly. Air is flowing on its own. Yeah. Yeah, so now you finally saw how I was thinking city bigger. Yeah. Yeah, that's definitely. I have a couple of items on the to-do list, so we can actually add this like arrow to show where the next target is. So yeah, some kind of gamification. I don't know. Right now it's just like a sandboxy thing, but maybe adding like score and time limit and high scores, and also some other challenges like you have cars that you can bump into. Maybe you can pick up like boosts or something. Yeah, making the city bigger, larger city, like procedural generation of the layout and stuff. You could do that. There's a lot of things you can do. Yeah, and pedestrians move out of the way when you approach them, so it doesn't look weird. Yeah, I think that's enough for today. But thanks for joining again, Varikos. It's nice having you here. and good night. See you some other time, maybe. All right, thanks. Bye.